4, 3, 2, 1, 0.
Hello everyone. Welcome back to a new video of Team Scientify. Hope you are doing well.
Welcome back to our channel. In today's topic, we are going to discuss about Thevenin's theorem and then solve one numerical with the help of this theorem. First of all, what this theorem states. According to this theorem, any two-terminal linear network containing energy sources and resistances can be replaced by a single equivalent circuit. So any linear network which is having energy sources and resistance, you can replace that by a single equivalent circuit, in which circuit you will have a voltage source VTH and a resistance which is RTH, which will be in series with the voltage source. Alright, this VTH is the open circuit voltage between the terminals with all the energy sources replaced by their internal resistances. So let us understand this even more clearly with the help of circuit. Okay, so let's draw the circuit. So this is the circuit. Here resistance R1, R2, this is R3, this is internal resistance, here voltage source, this is the load resistance. So let here be one point and here let be P. So if we just draw the arrow for the current, suppose this is I1 and along this load resistance RIL current will flow. So in the middle it was coming I1 and IL is leaving, so it will be minus IL. So this is the circuit. Alright, so first of all you have to replace this circuit by a single equivalent circuit which will contain VTH. So first, in order to find out the VTH, we will first so this circuit is in order to find the value for VTH, that is the VTH. So with the help of this circuit we can find out the value for VTH, and then what we will do, RTH. So for RTH you will remove the extra Vs. Here we had one voltage source, just remove that which was the voltage source, remove this voltage source, and it will be something like this, where you will only have, in this case when you were finding VTH, we were removing the RL which was the load resistance, which we actually have to find. Okay, but for this RTH we have to remove as well as the voltage source. So the final this will be something like this, where with this you will find out RTH. This is R2, R1, R3, and this is the internal resistance. All the resistances will be there, only we will be removing the voltage source and definitely the load resistance. Now the final circuit which we will get, this will be something like this. Let me give this point, this is AB. Okay, so this is the load resistance, here we will have the current which is a load current, this is the RTH, and this is VTH. So this is the final circuit of the Thevenin's theorem, where you will be having RTH, that is the last final RTH which we find from here, and VTH which we find from this circuit. So we will write this, but it should be in series. In case of Thevenin theorem, it is in series, so we have to remember that, and definitely the RL will be there. So let me tell in a brief in order to make it even clear. So first, this was our original circuit. Now what we will be doing in order to Thevenize a given circuit, first we have to remove the resistance, which is RL, this, okay, whose current is required, whose current you have to find out. So you have to just remove this. This is the first step we will be doing. Alright, then what we will do, we will calculate the value for VTH. Okay, we will be calculating the value for VTH by removing the RL. Then what we will be doing, then we will compute the resistance of whose network as looked into from these two terminals after all voltage sources has been removed. So you see, after all voltage sources has been removed, so we remove this voltage source and then we find the RTH. Okay, and we will be replacing the current sources by open circuit, that is infinite resistance. This is the Thevenin resistance or RTH. Then finally we are replacing the entire network by a single Thevenin source whose voltage is VTH and internal resistance is RTH. And then what we will do, we will connect RL back to its terminal. This RL which we initially removed from here, this we will connect it again back over here. Okay, and finally we will calculate, this is our final circuit, from where we will calculate the current which is flowing through this RL by using the equation I equals to VTH by RTH plus RL. So this we will be using in order to find out the current which is flowing through this RL. Alright, so this is the entire process of Thevenizing the circuit. Let me make it more clear with solving one numerical with the help of this. Suppose we have a question in which the circuit is something like this. This is the voltage source. Okay, so this is 40 volt where you have an internal resistance of 1 ohm. This is 3 ohm, 6 ohm, 5 ohm, 8 ohm. So what you have to do, you have to find current. You have to find current in 8 ohm battery, and battery has internal resistance of 1 ohm. Alright, so you have to find out current in 8 ohm. So how to do that? We will be applying Thevenin-Norton to this. So first of all we will find out VTH. How we will find out VTH? By just removing the load resistance, and all other thing will be there. So these things will be there, only we are replacing the load resistance when we are actually finding VTH. So this is 5 ohm, this is 6 ohm, this is 3 ohm, 1 ohm, and this is 40 volt. So when we find out VTH, let us first find out the current which is flowing. Okay, so current will be voltage which is 40 by the total resistance which we have. So if we see over here, in order to find out this current, over this 5 ohm there is no drop. Okay, when you just remove this 8 ohm from here, when 8 ohm is removed from here, there will be no drop across this 5 ohm resistor, so you will not calculate this one. So all we will be doing, just finding this 3, 6 and 1, this 3 resistances. You will only consider this 3 resistances as there is no drop in 5 ohm with 8 ohm resistor removed. Alright, so it will be 1 plus 3 plus 6, which will be equals to 4 ampere. So this is the current. Now if we find out voltage across 6 ohm, so it will be VTH. This VTH will be across, VTH will come like this. Okay, so which resistance you will consider? 6 ohm, so it will be current into 6, so this will come as 24 volt. Now we will calculate RTH. In order to calculate RTH, we will also remove the voltage source. So only we will have the resistances, and this will be our circuit and RTH. So RTH, how we will find out the RTH? We will remove this 8 ohm which we had. This we will definitely remove this 8 ohm which we had, and we will replace the battery by its internal resistance of 1 ohm. So here we had 40 volt, but this we will not take. Okay, so if we take our current in this way, okay, so here 3 and 1 ohm will be in series, so it will be 4 ohm, and that will be parallel with the 6 ohm. So it will be something like, and this will be in series with 5 ohm. So let me write it clearly first. So for this one it will be something like 5 plus 4 into 6, 4 plus 6, because this is in series and this is parallel with the 6 ohm. So here, and then 5 ohm will be in series with this. So calculated, it will come as 7.4 ohm. So now we will calculate the current in 8 ohm. This was our actual motto, to find out the current which is flowing through 8 ohm. So what formula we will be using for that? It will be VTH by RTH plus how much? RL. So VTH came something like 24 and RTH came 7.4 and RL was 8. So this will come something around this 1.56. So this is how you're going to find out I. This is the final answer. Now what will be the final circuit then? The final circuit will be RTH, which will be in series with VTH. It will be in series with VTH, and there will be RL given. So RL was 8 ohm. You got RTH which is equals to 7.4 ohm, and VTH which we got to be 24 volt. So this is our final circuit, and current is flowing through this, which is equals to 1.56 ampere. So today till this, I hope it's clear. This was all about Thevenin theorem. So today till this, thank you for watching the video. Stay tuned for more upcoming videos, and thank you. Bye bye.
This is all about today's topic. Thanks for watching. Hope you like the video.